Welcome back to the course Computer Programming for UR. In the fourth lecture of this course, I will go over functions in Python. Previously, we learned about if, elif, and else statements. We used them for making decisions based on one or several conditions. We also learned that if we have patterns in several continuous lines in a code, we need to turn that into a loop. We also learned that if the pattern is in the name of the variables, we need to turn the pattern into a list. You also learned about runtime errors, semantic errors, and syntax errors. You learned how to control exceptions or runtime errors using try and except statements so that the Visual Studio Code would not uh, show the error messages to the user by itself, but you as the coder have control on, the type of or the content of the error message that should be shown to the user. After watching this video, you can describe the syntax of a function in Python. You can explain how disconnected patterns in a code can be turned into functions. You can choose proper parameters and returning values for a function. You can explain the scope of variables inside and outside the functions. And finally, you are able to develop a function. Before starting teaching Python, I would like you to pause here for a minute and try to answer this exercise, which is related to what you learned in the previous lectures. As you can see here, this program gets two numbers from the user and turn them into integer. Uh, since they are strings, the numbers are stored in x and y. X and y are compared, and the larger number is stored in z, and finally z is printed. I'm going to use this program to teach how to create functions and why we need to create functions. We start with the syntax of functions. A function is a group of statements that can be utilized more than once. It has a structure like what you see here. It starts with def, which is a keyword in Python. Then you need to provide the name of the function. After that, you need to provide two rounded brackets, two parentheses, and in between you can leave nothing, or you can provide the names of the variables separated by comma. The first line of the function is called the signature of the function. And after that, in the next line, you need to provide indentation to uh, tell Python that these statements are related to the function. And these statements are called the body of the function. A function is called in the main program or another function by just using the name of the function and provide and then two brackets, and in between the brackets you provide arguments, uh, values, the name of variables or constants that are separated by comma in the order that is given in the signature of the function. Let's see an example of a function. Here, I would like to develop a function called max underscore no, that stands for max number. This function gets two numbers and returns the greater one. And we also want to write a code that uses this function. As you can see here, I usually use visual representations for a function. A function is shown by an oval that has a name here, max underscore no. Um, the ingoing uh, arrows shows the input arguments, and the outgoing arrows shows the output of uh, the function. As you can see here, this function gets two numbers, x and y are called parameters, while I and j are called arguments. The result of the function is also stored in K. This is, how we write, a function. Uh, you may know that the part that has no indentation is called the main body of the code. However, there is a specific name in Python for that. It's to underscore main, which we call donder main. This is the main part of the code which uses the function. Execution always start from the main body of the code. Actually, the first line of the main body of code. Here, line 7 is where the code starts. So the first code is that is the first line that is executed is I equal to 2. So a variable I is created in the RAM and 2 is stored there. After that, line 8 is executed. A new variable called J is created. And after that, in line 9, we call the function maxNO, and we provide I and J as the arguments for maxNO. Here, the execution Python jumps to the signature of the function, which is in line 1. X and Y are the parameters of this function. They are set to 2 and 3 respectively. And after that, line 2 is executed. X and Y are compared. Since X is smaller than Y, uh, it jumps to line 4, and Python executes a return Y in line 5. So 3 is returned. So the execution is returned to line 9 where we call the function. 3 is placed. Max NO is in a way removed and 3 is placed in place of max NO. So K is equal to 3. So a new variable called K is created in the RAM and 3 is stored there. And after that, K is printed in line 10 and in line 11, done is printed. So, sorry. So as you can see here, line 9 is the line that calls the function by giving 2 arguments, 2 inputs. This will require the function maxNO be defined before calling this function. So the execution of maxNO depends on the execution of line 1 to line 5, where the function is defined. This function gets 2 parameters and it can return, a value. So let's see how variables are created as a result of executing the previous program and the function maxNO. You may know that, even before starting a program, there are some default variables that exist in the RAM. Those variables are created by Python. An example of them is name, which stores, main here, donder main. That means that the name of the program is donder main. After that, the first line that was executed was I equal to 2. So a new variable is added to the RAM, which contains 2. Line 2 is executed, j equal to 3. A new variable called j is added to the RAM and contains 3. After that, the function maxNO is called. That means that the first line of the function, the signature of the function must be executed. Here, because we have two parameters uh, and a new function, uh, part of RAM is separated and uh, is devoted to this function maxno. Uh, Inside that part, which we call it local variables, um, the section for local variables of maxno, x and y are created and set to 2 and 3 respectively. After that, in line 5 to 7, x and y are used. And finally, when return y is executed, all the variables that have been created in this section are removed from the RAM, and only 3, which is the result of this function, uh, is returned to the main body of the program. So in the we now know that the result of the program is the function is 3. So k, a new variable, is created and added to the RAM, and 3 is stored in this variable. So after that, prints are being done, which have no effect uh, on the RAM. Most of you already know how to develop a program. Now I want to teach you how you can turn those programs to functions. In your programs, you usually get inputs from the users and you print something as the outcome of your program for the users to see. What you need to do is to turn all those inputs into parameters of the function and turn the print parse into return statements. As you can see here, we have x and y, where we get two integer inputs. We we use them, we use x and y as the parameters of this function max and o. We have print max is z, we need to print z, so we need to return z, which contains uh, the greater number between x and y. So after developing the function, it's time to use the function. You have to again get the inputs, but this time you can either store them in the same variables x and y, or you can choose new variable names such as I and j that are used here. And then you provide I and j as inputs of max and o. These I and j are going to be called x and y inside the function. And after that, the result, because I have a return in this function, there must be an equal sign and a variable name behind the name of the function in the main body of the code. And after that, I can print uh, the result of the outcome of the function. In developing the functions and calling them, you need to make sure that you call the function after defining that function. In this case that you see, the function maxno is called in the third line. However, the function is defined in the fifth or sixth line. That creates an error because the function is not defined. You cannot use it. The Visual Studio Code will return a syntax error. So always define the functions first. But why do we need functions? In the previous slides, you have seen that I turned a program into a function, then use the function to create the same program. Why should we do that? Here, I try to explain that using an example. You see two functions uh, on the right side at the bottom that have the same functionality. They get the same input, they have the same signature, and they return the same value. The only difference is that one of the functions use an extra variable, which makes that function use more memory because of using z, as you can see here, and it is also slower because it has to uh, execute two extra lines, z equal to x, z equal to 0, and either z equal to x or z equal to y. So that makes this program slower. So assume that you have created the slower version of this function and used it in your code to develop that program. After a year, you understand that this program can be uh, improved to be faster, uh, and you come up with the with the code on the left side. What happens here is that this would uh, you don't need to change the main code. You only need to change the body of the function, nothing else, to improve your code. However, if you had this code, if you didn't have a function, you have to change the main body of the function, the main body of your program. Uh, and that can be quite troublesome when you have, hundreds of lines of codes. So having function can make code maintenance faster and easier. Without touching the main code, you can improve a function to be faster, more accurate, or more secure. And also, functions can increase reusability of the codes. A function that is developed once by you can be used by you next year in other programs or can be used by other coders. We have GitHub where coders share their codes so that other users can uh, develop programs using those functions. So functions improve code maintenance and reusability of the code, which means lower cost of programming. Also, note that we can have different shades of a function. Shade is a term that I use. You don't see this in other, in the textbooks or, over the internet. It's after the movie 50 Shades of Grey. Uh, by shade of a function, I mean uh, if two functions that have the same functionality, but they have different forms. That means their signature, uh, the signature of the two functions are different, or the way they return the value to the main body of the code is different. So the exchange of data between the function and the main body is different, but the two functions do exactly the same thing. As you can see here, I have three shades of the function max number. So they all return um, calculate the maximum number, and they get two numbers, calculate the maximum, and return it to the main body of the program. The first one is already known to you. Uh, we use parameters to get input from the main body from the main program, the Donder main, and we use return to send output to Donder main. However, in shade 2, I removed the parameters. Instead of using parameters, I use the variables that are created in the Donder main. You see I and J are the main variables that we want to figure out which one is greater. Max and O uses directly I and J and figure out which one is greater and returns that to the main body, which is stored in Z. In shade 3, not only I don't use parameters to get input from the donor main, I also don't use the return statement to return the greater number uh, to the donor main. What I did was uh, using z, the variable that is created in the donor main, in the uh, in the body of the function, I start with global z, which means that z is the variable that is already created in the main program, and I put the greater number uh, into z. I set z to have the greater number. So as you can see here, the function does not create any new variables in shade 3. It uses the variables that were already created in the main body of the code to do the calculation and processing of those variables. Note that we can have 4 possible shades of a function. Uh, Domain can pass on a value to function using either parameters or global variables, as you just saw in the previous slide. A function can also pass on a value to domain using return statements or global variables. However, note that if you use global variables, you are not going to see those advantages of reusability and code maintenance easiness, uh, the advantages that I mentioned 2 slides ago. So we need to avoid using global variables, but still, you can you may need them, in some codes. The important thing is that you need to know that there are 2 ways to send a value to a function and return a value from the function. And based on that, we have 4 different shades. Let me explain how variables are created in Shade 3, where we only use global variables to exchange data between the function and the main body of the program. So as you can see here, execution starts from I equal to 2, I is created in the RAM, then J is created in the RAM. After that, Z is created in the RAM, and when you call the maxNO function, uh, it goes inside the function. However, since we don't have any parameters, the signature of the function does not create any values, any variables. And inside the body of the function, we have global z, which means that no new variables should be created. We use the z in the main body of the code, and I and j are also global variables, so no new variables are created by this shade 3 of function maxNO. So let's pause here for a minute and try to answer this question. Here is the answer. Pause here for another minute and try to create the 4th shade of function max number. Here is the answer. So to just give you a review of what we learned here, the domain can pass on values to function using parameters, x and y, or using global variables. That means I and j are directly used inside the function. function can return the outcome to non-domain either using return statements or global variables. So in return statement, you just send a value using the keyword return. In global variables, you use the variable that is already defined in the main body of the program. The creation of functions can make questions about the scope of the variables. The scope of a variable is those parts of the program that can read the variable and those that can change a variable. That shows the scope of a variable. Whether a function can change, whether the main body can change a variable, whether they can read a variable that is defined in another function or in the main body. We just learned that if a variable is not defined in the function, Python will look for that variable in the main code because the main code, whatever you define the main code, is part of the global section, and all functions can have access to that. That's how we created shade 2 and shade 3 and shade 4 of the function max and o. Let's see that let's learn that with another example. Here you see the function f that gets no parameters, but it prints x. Since x is not defined in function f, Python will look for x in the main body of the code. X is 3, therefore calling the function will print 3 as the output. However, you can see here we have print y in the function f. Since y does not exist in the main body of the program either, therefore the program returns name error. Let me explain the scope again using the max and o returning the greatest number program. You can see here that the code on the right is mapped to a visual representation where we have max number. The function gets I and j as arguments. It calls them x and y inside the function, and then k equals to 6, but k is not used here in any way. The outcome of max number is given to another function called print, so that print can do whatever it needs to do with that. So we already learned that in the previous slides. Here you need to know that if the print function tries to print x, it returns a name error because x is not defined in the main body of the code, and main cannot have access to the variables that are created inside the max number. Although x is defined inside the max number, the main code cannot have access to that variable. So keep that in mind. It's as if there is a border with security around max number that does not allow the main body to have access to those variables. We call I, j, k the global variables, as we just learned, and x and y are called local variables. So to put it in other word, the main body cannot have access to the local variables. So note that max and o, the function, can read the value of I and j and k, the global variables, but it cannot change them. So max and o cannot change the global variables I, j, and k unless you use global I, j, k to the function. the shade 3 that you saw a few slides back. And again, the DOM domain has no access to X and Y. Even if you add global X equal to 0, it doesn't work. Let me review what we just learned using another example. As you can see here, the function change is trying to set X to 3. However, we also defined X and set it to 4 in the DON domain. We know that the execution starts from the DON domain and X equals to 4. So what happens here is that the function change tries to set X to 3. However, we learned that uh, the functions although the function change can read the value of X and set it to 3 to be used inside the function change, but it doesn't change the X in the DOM domain. The value is going to be uh, untouched. That means X is going to be X is going to be still 4, and that's why you see the output of 4 as a result of running the print function. However, you can use the return statement, the return clause, and the value assignment in a way that you can see X is changed. How can you do that? You need to make sure that you have X equal to before the function change. Only in that case, when a value is returned, then X is changed, and then you can see, 3 is printed. But keep in mind that this is completely different for arrays, for lists, for dictionaries, for sets. A function can always change the value of a list. Here you see that in the main body of the code, we have a list called X. It has 4, 5, 6, and 7. When you try to use the function change to set the first element to 3, the 0th element to 3, you see that that element is changed as a result of the function. So lists are gonna always change inside the function, but what you can do to uh, avoid a list being changed is to pass on a copy of X. Here you can see that in the second program I created a copy of X called Y, and I passed on Y to the function change, and because of that the list is not changed. Try to pause here for a minute and answer this question. Here is the answer. Pause here for a minute and try to turn this program to a function, then try to develop all shades of this function. Here I only provide one shade of this function using parameters and return statements. You can study the remaining shades in the appendix. Now I would like to discuss some peculiar functions. You need to know that a function can return multiple values. So it's, so far you have seen that the return clause returns only one variable, but you can easily return multiple values by separating using comma. So when you do that, note that you need to have all those variables uh, repeated in the same order of in the same order that you see in the return statement in the main body of the code. So this basic operation function gets to value x and y, and it calculates all basic operations plus some addition, subtraction, multiplication, and so on and so forth, and then it returns them back to the main body of the code. Pause here for a minute and try to answer this question. This question is very similar to the question that you would see in the midterm and final exams. Here, I ask you to create a function called divide by 2 that gets two arguments, and returns two values. As you can see here, I gave you a code to test your program, to test your function. So that's what happens in reality in the exams. You are given a test code so that you can create a function for that. Here is the answer to this question. There are two options and also a wrong solution. I'm going to explain them in the interactive class. We can also specify some arguments to be optional. That means as the user of the function, you don't need to provide values for those parameters. They are also called default arguments. Defaulting means in mortgage context means failing to make a mortgage payment. So a default argument is an argument that a programmer is not required to provide value for. So as you can see here, in the basic operation, I specify equal to 2 for as the default value for y. So even if we don't provide the second argument, the function assumes that y is equal to 2 and it can do the operations. Pause here for a minute and try to answer this multiple choice question. Here is the answer to this question. So far, we have learned the syntax of the functions and peculiar function, as well as the scope of variables inside and outside the function. Now we want to learn how to identify a function in a code. So it's not as if that you start with creating a function from scratch. Most programmers, they see a pattern and then they turn that pattern to a function. Similar to loop, you need to start like a stupid programmer that has no knowledge of various kind of functions inside Python, has no idea of loops or functions. Then you try to find the patterns, and if the patterns are in several continuous lines next to each other, then you need to turn them into loops. However, if the patterns are in several different lines, they are disconnected from one another, then you need to turn them into a function. Let me explain identification of a function using a simple example. You see in this example, it gets an age and set x to that age, which is 22. Assume that this is your age. Then it calculates your age in century and in decades rather than in years. So y1 includes your age in century, and y2 includes your age in decade. After that, we print y1 and y2 using two sentences. Then we print now it's your mother's turn, and we assume that your mother is 55 years old, and we set x to 55, and then almost the same calculation occurs here. We calculate y1 and y2 and then print the same thing. And you can see the output of this program at the bottom. What I would like you to do is to pause here for 30 seconds and try to figure out what the pattern is. Okay, as you can see here, I can identify these two lines as the repeating patterns, y1 equal to x divided by 100 and y2 equal to x divided by 10. So this is what I see being repeated uh, in the program, but the lines are disconnected from each other. So the first step is to figure out what goes inside this pattern and what goes outside the pattern. That means what kind of variables we use from the previous lines and what variables inside the pattern are used in the next lines. You can see here that we use x from the previous lines and we use y2 and y1 in the next lines. So this shows the parameters and the return statements of the function. Uh, so we use x as a parameter, and we return y1 and y2 as the outcome of this function. So we start with writing def and the keyword def and then a space, give the function any name that you want. I just call it f here, and the parameter is x, so you just need to write down x in between the parentheses and then put a colon. Then you copy the pattern and put it inside the body of the function. y1 equal to x divided by 100 and y2 equal to x divided by 10. After that, you need to return the values that are used in the next lines, which is y1 and y2. Now it's time to, so the function, now the function is complete. You need to use this function. To use this function, to call this function, as you see, we have two returns, so we need to have two variables separated by comma first, in this case a comma b, and then equal to use the name of the function and then provide a variable like t. So that's how you can call this function. So now it's time to rewrite the program using the function. Note that we always have to put, we always have to place the definition of the function before calling that function. So as you can see here on the right side, I started with the definition of the function. Then x equal to 22 was not part of the pattern, so I'm going to put it there. Now I'm going to replace the pattern with calling that function. I'm not going to define new variables here. I'm going to use the same variables. So I would say that fx, x is an input as an argument to the function f, and the result should be stored in y1 and y2. And after that, I simply print y1 and print y2, as you can see. And I do the same for the next pattern, the second pattern in the code. I'm going to, I need to replace that with the function f as well. Okay, now here, I still can find a second pattern in this code. I can see that that there is a pattern in this code that starts with setting x to a value, which is 22 or 55. Then I call the function fx to have to set y1 and y2. And after that, I do a kind of printing. So what I need to do is to figure out what part of this pattern is changing and what part of this pattern is fixed. As you can see here, the value of x, the value that is that x is set to is different. It can be either 22 or 55. Also, in the print function, for the case of 22, we have you have lived for blah blah, and in the case of mom's age, we have she has lived for. So you have and she has are also being changed. Now it's time to turn this pattern into a function. We start with turning the changing parts into parameters. So in the signature line of the function, we start with the keyword def, then a blank space, then we need to give a name. I call this function G, and then parentheses. In between the two parentheses, we have x as an input, as a parameter to this function, and also s, which can be given values like you have or she has. And after that, since x equal to 22 is already done by the first line, the signature line, I just need to repeat the next three lines here, y1 comma y2 equals to f(x), and then here in the print function, I also need to replace the value, the changing part of you have with the parameter s. So that's what has been done here. Okay, now we need to rewrite the program using the second function. Again, we need to define the function g first. We add g right after the function f, the definition of g right after the function f, and then we need to replace the patterns with calling those functions. So the pattern will be replaced with g in parentheses, and in between the parentheses 22, and you have. Then we need to uh, write down the print function. Now it's your mother's turn. And then we need to call the function for the second pattern, which is G, and in between parentheses, we need to provide 55 and she has. So that's how you turn a raw program into functions, and then rewrite the program using those functions. We just learned how to identify a function in a simple example. There is a more complex example which is about uh, fraction operations. For example, we want to give the fraction of 3 over 4 and the second fraction of 1 over 8 to the program, and then have the program calculate the sum of the two fractions, the subtraction of the second from the first fraction, the multiplication of the two fractions, and the division of the first fraction by the second fraction. So if you try to be a stupid programmer, you will use but you only know how to turn continuous lines to loops, you will create a program like what you see on the left side. However, there are many patterns in these codes in several different lines, some discontinuous patterns. You can turn them into two functions of GCD and simplify on the right, and then rewrite those programs, the program using the two functions here. I don't want to go to the detail of this. This is in the appendix, and you need to learn how I found the pattern in the code and how I turn them into this new program with two functions. Okay, here's an exercise. Pause here for 2 to 5 minutes and try to answer to develop a program. Find the pattern and replace it with functions. And here is the answer to this exercise. We'll go over that during the class, the interactive class, if you want to. In a nutshell, in summary, functions are used when a pattern of code is repeated in different parts of a program. To find the parameters of the function, you need to figure out what variables from the above lines is required inside this pattern, and what and to figure out what the function needs to return, you need to figure out what variables inside the pattern are used in the next lines. And that can help you to write down the return statements. The appendix section explains several interesting things about the functions such as docstring, keyboard arguments, functions with arbitrary number of parameters like the print function, and it also provides, two more examples for what we already learned. Uh, I provide 50 shades of a function here in the appendix, and also identification of complex functions. If you have any questions, please come to the interactive lectures or ask them on Canvas. In the next lecture, I will discuss modules and recursive functions.